Have you ever wondered about what is the best time to take your pill, especially if it's encased in gel? We often hear conflicting opinions of whether to take the medicine before or after the meal. My project aims to answer these questions using an experiment designed to examine pH effects on the drug delivery of gelatin-based capsules. Let's first look at gelatin. Gelatin is a very unique material as it is a polyampholyte. This means that it has a mixture of both positive and negative charges on its amino acid backbone, which means gelatin has ionizable side chains that are easily influenced by their surroundings. Note what I just said, surroundings. And when the surroundings changes, this means the material properties of gelatin changes as well. And remember, it's because gelatin is a polyampholyte. Now let's look at one way the surroundings can change, which is pH. What is pH? Well, pH is a measure of the hydrogen ion concentration or the proton concentration of a solution. In low pH, the amino acids are likely to take up a proton, therefore making the gel molecule surface positive, allowing repulsive forces to dominate, because remember, like charges repel. However, at the isoelectric point, which for gel is around 4.7 pictured on the diagram, attractive forces dominate because this is the point where the negative and positive charges balance out, and remember, opposite charges attract. Therefore, my hypothesis is that near the isoelectric point, due to the opposite charges, the gel capsules will take more time to separate and therefore allow for slower drug delivery, versus near a pH from 1 to 3, which is far from the isoelectric point, the charges are like, and the gel capsules will separate faster. Now that I have my hypothesis, I need to determine the pHs that I should take my experiment at. So therefore, a study by Gardner et al., which measures the meal-stimulated gastric acid secretion by in vivo gastric autotitration, shows that when the participants were taking a meal consisting of lean steak, boiled potatoes, fresh vegetables, salad, dessert, and water, their stomach pH was measured, and a pH of 1 was reached before the meal, a pH of 4 was measured right after the meal, and a pH of 2 was measured 90 minutes after the meal. Therefore, the three pHs that I will take my experiment at are a pH of 1, 4, and 2. And my experiment will go on to test all of these pHs and determine at which pH does the gel capsule separate the fastest and test if my hypothesis is right. Let's do it! For this experiment, you'll need some pH test strips, some white distilled vinegar. For this experiment, I used ones with 5% acidity, which you can find easily in your supermarket. Next, you'll need some gel-coated pills. For this one, I just used Dayquil pills and something to measure with. And also some styrofoam bowls. And don't forget some chemical-resistant gloves. So for the first experiment, I used a pH of 2, which is 90 minutes after your meal. And the reason I chose to do a pH of 2 first was that when I tested the 5% vinegar, it was already at a pH of 2. So I didn't really need to tinker with it. So I went ahead with the pH of 2. And as you can see, it matches up. On my first trial, I did fail because as you can see, for the two pills that I tested with, one which is an omega pill and one which is a Dayquil pill, both did not separate at all during the duration of the experiment. So I began to devise a plan to mimic the stomach better, because what the stomach has that what I didn't was convection. The stomach will often move, or since we walk around, it'll move and twist. So I decided to repeat the experiment, but stir every 10-minute mark for 2 minutes to mimic that movement or adding the convection to the pill. And as you can see, at around the 1 hour mark, the pill began to separate, as you can see. And it was really cool now looking back to see it separating. As you can see, it's splitting. And then actually I reached the 10-minute mark, so I began to stir. And while I stirred, it separated even more. So for the pH of 2, it took about an hour. Next, for a pH of 1, which is before the meal. So for this experiment, I had to make the pH lower, so I did this by heating up the vinegar. And I did this for multiple times, and the point of heating it up is to evaporate all of the water so that the acetic acid concentration is more concentrated and lowering the pH. And this was the best I could get, but I'm still not very convinced that this method works to lower the pH. So as you can see, the pill for the initial 1 hour or so did not really show any results. But around the an hour and 30-minute mark, the pill began to separate, as you can see. Next, we need to get to a pH of 4, which is right after the meal. And for this, I was starting with a pH of 2, and I did trial and error and got to a point where I found out that a 200x dilution works the best to get the pH of 4, which I achieved here. Which is just 199 milliliters of water and 1 milliliter of the 5% vinegar solution. And this pill was very stubborn. For some reason, well, I have theories later, but it just would not dissolve, and I decided to stop at the 4 hour mark. And here are the final results. So we have a pH of 1 that separated at 90 minutes, and a pH of 2 that separated 60 minutes, and a pH of 4 which took 40 minutes plus of time. And this somewhat lined up with my hypothesis, as I expected the 4 pH solution to take much longer. However, I didn't expect the results where a pH of 1 took more time than a pH of 2. My hypothesis is that my technique for burning off the water to have a more concentrated acetic acid solution was not successful, and therefore I might have also burned off the acetic acid because I never did really achieve fully 1 pH. So possibly by somehow burning the acetic acid, it made it less active, but that is the final result of the solution, and the pH of 2 wins. So taking your pill 90 minutes after your meal would show the best pill separation. But correlation does not mean causation. But yes, that's the result of my study. Thank you for watching.